Hello, friends. Welcome to another Live Code Tuesdays. My name is Sohan Maheshwar, and I have Ryan here with me today. Today, we are going to be talking about spin test. Essentially, this is a very new and it's a very new framework. It's something that Ryan's been working on for the past few months. And essentially, we'll talk about how to test Spin and WebAssembly apps and how it works under the hood. There's a lot of interesting stuff that's going on under the hood that Ryan would like to show us. And yeah, that's what we're going to do today. Folks joining in, I can see Vamshi and Peter already here. Thanks for joining in, folks, early birds. And if anyone else is there, let us know where you're streaming from. I always ask that because we get a fairly international audience. Ryan, welcome again to the show. It's been a while.
Yeah, it's good to be back.
Nice. Well, so Ryan's going to show us spin test today, right? And this is something that he's been working on for a while. It is open source. You can check it out on GitHub. We've even written a blog post about it, but Ryan's going to talk about how he worked on it and how it also works with a live demo, the usual format that we follow here. So Ryan, over to you.
Awesome. Yeah, so today we're going to be talking about spin test. So I think the best place to start is on GitHub with the spin test repository. So this is completely open source. I think the first thing to know about it is that it's very new. So there's going to be lots of interesting things that are not quite done yet or fully fleshed out. And so there's plenty of opportunity for contribution in some way. So don't hesitate to stop on by the repo, leave issues, open pull requests if you want to. But enough about that. I think the thing to talk about is what is spin test. So in order to understand spin test, I think the first thing you need to know is what is spin. So spin is a serverless framework for running WebAssembly applications. So you're going to write a WebAssembly program that will be run sort of in a serverless event-driven fashion, where, for instance, if you're running it as an HTTP server, the application will be instantiated when an HTTP request comes in. The request will be sort of run through your WebAssembly application, and it will return a response back to Spin, and then the entire application gets kind of brought down again, and if another request comes through, the whole cycle repeats. And so at the core of this is this WebAssembly application that's running. And now the thing that spin test is set up to do is to make sure that we can test that WebAssembly application even when we're using a whole bunch of different functionality. So your application might be talking to a whole bunch of different external services, like a key value store or a large language model. It might be talking to a database of some sort. It might be talking to various other HTTP downstream HTTP services. And if we want to test our application, the kind of traditional way to do that is to start up the application and throw a curl request at it and see what happens. But of course, that requires making sure that you have everything that the application depends on already running. And of course, if you've got a lot of stuff, that's that could be quite a lot of things. And of course, we also wanted to run these tests not kind of manually, but in CI or running kind of in an automated fashion. And so wouldn't it be great if we could all kind of make sure that those downstream dependencies of our application are just kind of handled for us and kind of in a way sort of mocked out for us, and preferably in a programmatic fashion. And that's exactly what spin test does. Spin test provides a way for you to write tests where your application is sort of composed together with a virtual spin runtime, where all of your different dependencies are kind of mocked out for you. So if you make a call to a key value store, it's not going to actually go to the real key value store, which usually is a SQLite database or maybe even something running in the cloud, but instead it will go to this virtualized environment, and that virtualized environment is also configurable by you inside of code. And we'll see how this works in a little bit. where you can say that I expect my key value store to already have data in it, or to to be populated with these keys and these values, so that your tests can sort of set up what you expect the world to look like, have your app run against that world, and then you can make assertions about how your app has changed the state of the world.
Okay.
Um,
And Ryan,
so
I'm sorry to butt in, but
no, no.
for those who might not be familiar with the concept of a world when it comes to like WebAssembly and components, can you tell us a bit about that?
Sure. So I shouldn't have used the term world
Yeah.
here, I think, because I
Okay.
actually didn't mean the WebAssembly world
Okay.
in this case. But what I meant by running, the world that you're running in, what I meant by is like the all the assumptions that your app has about where it's running and what is available to it. So let's take an example of an app that targets a key value store, or talks to a key value store. It expects that key value store to be running, and there's nothing inside of the application that makes sure that it's like, there's nothing in your app that says start the key value store now and make sure it's running, and if it's not, restart it again. That's all taken care of by the framework, or by whatever you're running, the environment you're running in. And so spin test sort of abstracts all of that away, and says the environment that you're running in, I'll provide you sort of a virtualized environment that runs entirely inside of WebAssembly, and provides sort of a mocked out version of that environment. We'll see what that looks like when we go to the live demo, exactly how that's set up. Um,
Okay.
I can still explain what worlds mean in WebAssembly, but it's not
Yeah,
necessarily
it's not.
relevant to.
Yeah, all right. We'll skip that one for now. Then I think we'll probably have a future stream where we'll have to talk about like that,
Yeah,
but let's skip that one for now. Okay.
cool. Yeah. So real quick about how spin test is meant to be run. As you can see here in the README, spin test can be run as a standalone binary, but we'll talk about it sort of in its most native format, which is as a spin plugin. So spin space test. It's not included in spin by default, so you have to install it with spin plugin install, and you just point it at this fancy URL. We'll give you the canary release. Canary release is sort of just the whatever is on the main branch release, like the latest and greatest. We don't yet have versioned releases because this is also new, which that kind of tells you a little bit about where spin test is at this exact point in time. But eventually we will have, version 0.1, 0.2. But for now, when you install it, you're getting kind of the very latest, whether it works or not. So I try to keep it working well on the main branch, but be on the lookout for that. So once you do that, and you have it installed, then we could go through the README here, but I think it's best to just show a demo instead, because that might be better to do. Should we do that?
Yes, absolutely.
All
Get
right,
started. Yeah,
great.
Peter says when you mentioned world, he had Unreal Engine flashbacks. I haven't worked with Unreal Engine, so I'm not sure what the worlds are there. Although I think one of the greatest levels of any computer game ever is facing worlds in Unreal. If you played it way back, I'm probably giving away my age that I played the original Unreal, but yeah, that was a fun game.
For sure. Yeah, I
Yeah,
remember late nights of playing Unreal for sure. Yeah.
yeah,
Awesome. All right.
yeah. Go.
So I have a spin application here. It's written in Python. I picked Python because I don't know, because Python. We'll have a couple of other languages today that we can talk about. And it's important to note that spin test works against any spin application, and it doesn't matter what language it's written in. So you can write applications in whatever language is supported by spin, which is anything that can run WebAssembly components as a guest language, which is a growing number of languages: Python, JavaScript, Go, Rust. C Sharp is getting better and better support, a whole bunch of them. So you can write your spin apps in whatever language you want, and you can write your tests in whatever language you want as well. And they don't have to be the same language. If you want to write your app in Python and your test in Rust, which is what we'll be demoing today, that's totally fine. If you want to write both in the same language, you can. If you want to write different languages, it's totally up for to you. So yes, Rust for the win. Exactly. Um, so So we're looking today at this simple application. I'll just talk real quick about what it does. So it's kind of a very simple like user lookup app. So we're getting in a request, and we expect there to be a user ID in the query string. So we get that out, and then we open up this key value store. So this is a store of key values that we called cache. And we try and look up the user's information by the user ID inside of that cache. So that's what this line is doing. And then it checks like, okay, well, did we get a user back? And if we didn't, then we call some downstream API like my.api.com, and we pass in the user ID, and we get back the response, which we assume is the user JSON, and we set the user inside of the cache, and then we return that back. So this is sort of like a user lookup where we put a cache, a key value cache in front of it as well. So, little simple app that we have here. And if we want to go ahead and run this app, then we can do the whole thing of spin build, where we build the application, and then we can do spin up like this. And oh, of course, I haven't. I have a misconfigured thing, but no mind. We can go ahead and get our app running, where we'll run it, but then we have to kind of test everything manually, where we run the actual web server and we throw curl at it and see that it works. And of course, if my.api.com isn't a real thing yet, like maybe we haven't even created it, well, we're out of luck then, right? So then, traditionally what we would do to solve this is like have some kind of like mocking framework in Python that goes ahead and mocks all of this out. So it says, well, if I call myapi.com, like don't actually call it, instead hit this mock version inside of my app. But of course, you're skipping over a whole bunch of your actual application's code there. Like imagine your app does some DNS trickery or something like that. Like you'd be skipping over that. So what spin test does instead, it says, no, go ahead and make that API call. And when it leaves your application and actually exits the WebAssembly component itself, then I'll be there to kind of mock outside of that. And that's what allows us to be completely language agnostic. Is it's nothing is happening inside of your code. Your application runs completely unmodified. There's no changes to your code, and all of the mocking that happens outside of your application. All right. So how do we set this up? How do we actually kind of opt into running spin test? Well, if you look in here, this is a spin.toml, which if you've written a spin app before, then you should be familiar with what this is. This is all normal stuff, application metadata. We talk about our HTTP trigger. We kind of configure our component here. This is how our component gets built. And the only new thing that we have with spin test is this down here, this extra information about spin test. And this is where we're going to say, I have a WebAssembly component, another one, that represents my test, and I want you to run this test. And you can provide a couple of extra things here about how to build the test and where the build command gets run and all of that stuff. But this is the key part here. I've got some WebAssembly component that is a test for this. And in just a second, we'll see how to build that WebAssembly component. But that's all you do. And then all we're going to do there is then run spin test, and it knows how to run that test, and we'll show you what the test actually looks like. And so we have our test running now, where we test a couple of things. So I'll stop there before we take a look at what does the test actually look like. We've seen spin test running. We've seen that we have a couple of tests, and our app is passing, which is great. And I want to stop there and see if there are any questions or any thoughts from anybody about this.
Yeah, folks, I think a bunch of folks just joined. I see Marco, Saurav, Kedar. Oh, hey, Kedar. Yeah, thanks for joining in, folks. So just as a bit of a recap, we're looking at testing WebAssembly apps, specifically the spin test plugin that Ryan has been working on. It's something very new. It's still very much in development. So, you might encounter some sharp edges when actually working on it. It's on GitHub and it's completely open source. So feel free to check it out here. The cool thing, as Ryan was mentioning, is that you can write your WebAssembly or Spin app in one language and write your test in a completely different language, right? And so far, we've just got to the stage where he's shown a demo of the test, but we'll be, doing a deep dive in a bit and talking about it a little later. So there's a question from Peter, which is this going to allow for stepping through code with a debugger attached? I'm guessing yeah. So, yeah, right.
Yeah. So there's nothing about this that hinders attaching a debugger or helps it. So the answer is sort of as good as WebAssembly support for debugging is, which is a evolving topic. It's definitely not as good as it will be in the future, and it's much better than it was in the past. That's for sure. This still allows you to do that. We don't have any kind of built-in support for once my test starts running or I hit my app, then set a breakpoint thing. Maybe that can be added in the future, but there's nothing special about this that would prevent attaching a debugger at some point. So that just debugging is something that needs to be improved in general in WebAssembly. Cool. All right. So let's take a look at the test itself. So we have our app here. We've seen what it looks like. We know we've actually can run some tests against it. But what does it look like to write the test? And we'll take a look at this here. This is our test. And like I said before, we could write this test in Python if we want to. We could write it in JavaScript. We could write it in any language that has WebAssembly component support. I'm a Rust developer, so I picked Rust. But you pick whatever language makes you happy. And we'll take a look at what these tests actually look like. So in this is testing our application by doing two different tests. One, what happens when we hit that cache? So we saw before here that we have a cache. What happens if there is a user JSON for that user ID already in the key value store, and what happens when there's not? So those are sort of the two scenarios that we want to test, and we'll test both of these. The first one is where the cache is already full, and we do that by first filling the cache. So you can see here's the user JSON ID 123 and name Ryan. That's me. And we'll go ahead and before our app is even running, we'll open up that key value store cache, and we'll set the value 123 to that user JSON. And then we go ahead and this has just been factored out into a common function here. We'll actually make the call. So we have an outgoing request. We set the path with query to / and then the user ID equals 123. And then we actually perform the request. We make the request and then we get back a response and we can make assertions about that response. So we want to make sure we get a 200. And we want to make sure that the body that we get back is equal to the user JSON that we passed in. So this is where we're making sure that our request was successful. And you can see we can make additional assertions as well. So we can actually look at our key value store and get what calls have been made to the key value store when our app was running. And we can see that there was only one call to our key value store when our app was running. It was just a call to get. So we can verify that there was no, we didn't call get 17 times, which would be unexpected, right? If we just called get in a loop, that would be a performance regression. We want to make sure that we're only calling it once. We can make sure of that. And we make sure that we're not calling set, for instance. We're just calling get once. And for the cache miss, it's the opposite. We're not setting the cache store here, but instead what we're doing is we're configuring a mock response. So this call right here says that in your app, when your app makes a call to my.api.com with user ID equals 123, then I want you to return back this response. And the response is just the user JSON that we saw before. So this is what is mocking out that call to the downstream API. And then we make we make the request again, we make the assertion that there was a 200 and that the body is equal to the user JSON. That's all good. And then we take a look at the cache again and say, okay, well, and when our app was run, what did the key value store get called with. And we can see not only did it get called with the initial check of is it set, it also got called with set itself. So do we have it? No, we don't. Then we set it. So we verified that the key value store is sort of being interacted with in the way that we expect it to be interacted with. And and we can make sure that when we actually get we interact with the key value store afterwards, and we get the value that's at key 123, that it's also set to the user JSON. So this is kind of a full verification that our application is running the exact same way that we are expecting it to. So I'll stop there, see if there are any questions.
Yeah, I think we just have the one question, which I'm not sure I quite understood, Marco, which is, can I run it in BigQuery? If I'm not mistaken, is that a Google Cloud specific software? In which case, the answer would probably be no, because well, I mean, at least the Spin test framework is specifically for Spin apps. If you talk about Spin itself, you could run Spin via SpinCube on Google Cloud, right? Like maybe in GKE, I think it's called Google Kubernetes. No, is it called GKE? The
Yes.
Elastic, I know the Google's Kubernetes, Google Cloud's Kubernetes service, essentially. Yeah, but if you want to like clarify your question, perhaps, Marco, we'd be happy to answer it. Yeah.
Cool. Yeah. So that's basically it. And you can see here we can, when in our application in our spin.toml, we're telling Spin test how to build our test, and we do that through Cargo Component. Cargo Component is a tool for building WebAssembly components in Rust. But this is whatever your specific language that you're using, you use the build tool that is appropriate for that language to build a WebAssembly component. So again, tests can be built in whatever language that you want to, as long as that language supports WebAssembly components. And that's basically it. That's the demo. So yeah.
Nice. All right. So that's how it actually works, Ryan. So you also mentioned maybe we could take a look at how it works under the hood, because there's like a lot of cool stuff with like components and things that are happening, which basically enabled you to even build the Spin test plugin in such a way, correct?
Yes. So the cool thing about this is, and this is a little bit hard to kind of show in a concrete way. Well, let's see here. If I can go to, do I have? Let's see. I have the same app written in Rust, by the way. Here's let's open this up real quick. I can just show that off real quick. Let's imagine we rewrite our app from Python into Rust, for instance, because I don't know, performance or to be cool kids, we want to rewrite it in Rust. Then this is the same app here, with a couple of other things that I show off, like the fact that you can use Redis here, and if we run this, then we're running the same. It's configured to run the same test, and we see that our app is actually running. So we didn't need to rewrite our tests at all for this rewrite of the app. The tests and the app are completely separate from each other and don't need to. They need to know about the logic of one another, but they don't, or the test needs to know sort of what the app is meant to do, but it doesn't need to know anything about what language it's written in or anything like that. So, and you can completely switch the app out with a new implementation and run the tests again and know, okay, if the tests pass, then my app, which has been rewritten in a new language, functions exactly the same as the previous app because the tests pass, which is really, really, really neat and a powerful thing, I think. So. But that aside, let's see, do we have, Spin test. This is, oh, I have, it's a different version. Yeah. So I can't show, unfortunately, because my machine's all borked since I'm actually working on a new feature for Spin Test, and I've completely ruined everything. In the meantime, I can't really easily show this off. But there's a way in Spin Test now to actually um, take your application and run spin tests over it, so that it doesn't run the tests, but it takes your app and it takes this virtual environment that we've talked about for that composes um, uh, that this virtual environment that your app will run in during spin test when the tests are actually run. It just takes your app and that virtual environment and puts them together and then gives you a new WebAssembly component. And so this new WebAssembly component can run anywhere that components can run, and it runs as if it's running in that spin test virtual environment, but it's not running a test against it. And that's actually how spin test works. So when you run spin test, it takes your app, it takes this virtualized environment that kind of mocks out everything, and it composes them together using WebAssembly component composition. And what WebAssembly component composition is give me two components or more and create a third component, a new component that is literally just the two kind of glued together. Um, and so spin test knows what your application kind of depends on, what it's importing into it, and it can take your virtual environment that exports those things and supplies those dependencies and plug them together like little Lego bricks, you can think of, and produce a new component that runs inside of that virtualized environment. And then you can run that kind of in any runtime. You don't even have to run it in Spin. You could run it inside of WASM for instance, which is just a plain WebAssembly component runtime. You could run it in Jco in the browser, for instance, all because it's all it really depends on at that point is WASI and nothing else. So
Yeah.
that's pretty cool.
That is very impressive. One question I had, Ryan, is when you're combining like two components from WebAssembly, right? So you have the spin test and your WebAssembly app. How do you know one imports some things and the other exports that, right? So how do you dynamically figure out what needs to be imported and exported before you put them together like a Lego brick?
Yeah. So we make a couple of assumptions. For instance, let's take a look. I'm not sure if everybody. Let me make this a bit bigger so we can see it. I'll go up here. I'm actually in the spin test repository here. And do I have WASM tools installed? Cool. So WASM tools is a suite of tools that lets you kind of play with WebAssembly modules and components. And one sub tool of WASM tools is this WASM tools component wit command here. Let me clear my screen. WASM tools component wit can take a WebAssembly component and show you sort of the world. We've talked about worlds before. Maybe actually I should talk about what this. I really do mean WebAssembly component worlds. Let's see if we can. My Rust app is right. Where is it? Oh, it's in, of course, WASM 32 release my app.wasm. So this shows all of the things that that my app is relying on. And in fact, it's actually more than I would expect. So I'm maybe I have an older version that's running here. But anyway, this shows you these are all of the imports, all of the dependencies that my app depends on. And so my app can only do the stuff that I provide it here. So we have things like accessing Redis, for instance. We have things for talking to TCP streams and UDP streams, for instance. But there's no import for talking to, for instance, Kubernetes cluster. There's no import for that, and so my app can't possibly talk to a Kubernetes cluster over some kind of specialized import because it's just simply not there. And all of this composed together is essentially makes up the Spin world. Spin has a certain number of things that it can provide your application, and it expects that your application exports or provides this incoming handler that allows it to be executed as a handler of HTTP requests. And if you pass in a WebAssembly component that doesn't have that shape, if it doesn't conform to that world, as we say in WebAssembly parlance, then you'll get an error saying, I expected you to have this certain shape and you didn't have this certain shape. And spin test relies on that as well, knowing that spin applications have a certain shape to them. And the spin test virtual environment also has a certain shape. And that certain shape is, in effect, like the mirror image of your spin app's shape. Like it looks just like your spin app, but instead of importing all this stuff, it exports all that stuff. And
Got it.
what's really cool about that is you can take those exports, the things that the virtualized environment provides, and then plug it in to the stuff that your app is expecting or requires, and then you end up with something that doesn't require anything because all of its imports have been satisfied by this virtualized environment. Does that make sense?
Yeah. No, that's awesome. It's very cool, and it's almost. I keep saying this when talking about components and WebAssembly in general. It's kind of a very different way of thinking about, like different pieces of code interacting with each other, and it's like a new paradigm almost. Right, so I think it's extremely cool. I'm biased, of course. There's a question from Peter, which is, so this in essence takes the place of having a separate test infrastructure to deploy to. Would this be added to a CI/CD pipeline? I would assume so, Ryan. Oh wait.
Yeah, exactly. Yeah, the point here is exactly that. You want to be able to run tests that exercise your application in an automated way, which is usually through CI of some sort, right? Like you're running on GitHub Actions. And maybe in the past, what you've done in order to do that is to have a whole bunch of like integration tests, and you have this whole test runner that does things like set up. Okay, my test relies on a database, so I'll like have a test runner that like calls Docker and like Docker runs a database so that there's like
Yeah.
a database running next to it. And I also require this like downstream dependency of for HTTP service that I rely on. So I'm going to like also run like an HTTP server that like mocks out that downstream dependency. And so you end up with very complicated and fairly brittle infrastructure running in your CI pipeline for like kind of creating your test environment. And some environments are so complicated that you just kind of like don't do it. Like at some point you just say my environment is so complicated that I can't test it anymore. I've been in a couple of teams before where it's like, well, we don't even know how to test our app except manually because like our environment that we require to run our application is so complicated that running it in CI is just not possible. We just can't do it. And the hope with spin tests is just get rid of all of that. So your app still runs, it runs unmodified, but it's running against this sort of mocked out environment that does its best job of mirroring your real environment, but in a way that's much faster. So it won't completely eliminate the need to run your actual environment, because of course there can be some difference between this mock environment, this virtualized environment that you're running, and your real environment. They're not the same thing, obviously. So if there's a difference between the two, you can end up with bugs there. But then the nice thing is that you can do this much more quickly. So you could run these tests. Spin tests can run in a matter of a few milliseconds, whereas setting up an actual environment may take minutes or tens of minutes to do properly. Which there's a huge difference between the two.
Very cool. Very cool. Question from Bunny. Hey, Bunny. Welcome to the show, I guess, one of our regular viewers. Does spin test take a test suite like a Perl script or some other HTTP testing sequence? And there's a follow-up to that, which is, for that matter, if the spin app is more than plain HTTP, then would it allow like Selenium, Jest, and these other testing suites?
Yeah, so no, spin test does not accept some sort of like declaration or outside declaration of HTTP requests, as we've seen here. For instance, this is what the tests actually look like. So you write your tests in code, and again, they can be written in any language that supports WebAssembly components. So Rust or JavaScript or Python, any language. And these are just components. They're WebAssembly components that conform to some spin test world that give you a certain functionality. So this is all running inside of WebAssembly, and you can see, right, it's in this function here, make request down here that's been factored out. But this right here, spin test SDK perform request, is where the request is actually made, and you're not really making an HTTP request. There's no sort of like, there's no TCP connection that's being established. You're not actually like going over a full networking stack. Your test, your application has a handler. That's how spin apps work, that say, give me an HTTP request and I'll give you an HTTP response. And effectively, what we do here is this handle function right here is your application's handle function. So when this spin test SDK calls handle right here, it just takes the request object that it created and it just hands it off to your application. So there's no network stack, nothing is happening here. It's directly from your test into your application. And as we've seen before, like, if you switch out with a new application, as long as that application has the same logic to it, then that works just fine as well, because these are sort of binded late. They're composed together at the very last minute, where your test and your application are put together, and this connection between the test and your app happens at the very last minute. So you can switch it out with whatever application written in whatever language you want to. Hopefully that answers that.
Yeah, and this is my question, but say like you add like a I don't want to say module, but say you update your app, right? So you add like new functionality and that sort of thing. Does that mean the old test then is completely irrelevant, right? So you have to add the testing of the new functionality to a new spin test module that would bind to that app.
Well, let's go back to this let's see, this app here. So this app, like, we didn't go quite through this code because it was written in Python, but it's the same in essence thing. You're calling a key value store, and getting back user JSON, and if it's not there, then you call some downstream API, and then set it in the key value store. So as long as for a certain request, like imagine this will run at the path / so myapp.com / runs this. But we add a new endpoint that's like myapp.com / foo or whatever, and it runs something completely different. Well, my test is only testing the / endpoint. It's only testing that root endpoint. And the root endpoint hasn't changed at all. And so the test itself doesn't have to change. Like, the assumptions still hold. And sure, if you add like, well, I don't want to call myapi.com, I want to call ourapi.com instead, then your test will have to change, because the assumptions that your test works under change, if that makes sense.
Got it. Okay. Yeah. Awesome. So another, I think, sort of follow-up question for Bunny. So it sounds like it's more of a replacement for the unit testing stage and not the comprehensive integration test.
This is I'm smiling because this is a very we've had a lot of discussions internally at Fermion about the terms unit testing and integration tests, and everybody has a different definition of what they mean. So the answer to this question, I think, is like yes and no, depending on what you mean by unit testing and integration testing.
It depends, basically.
Yeah, it depends. So if if what you mean by unit tests is like things where you don't have to run some kind of external service or some kind of external software in order to get the test to work, then yes, like this is a unit test, and that you never leave WebAssembly. I personally don't use that definition for unit testing. Unit testing to me is like small functions internal to your application, where you don't use any kind of like the control flow never leaves your application.
So you wouldn't test like an HTTP API, for instance, in a
Exactly.
traditional unit test. Yeah.
Traditional unit test.
Yeah.
So like under that definition, then no, this isn't unit test. This is an integration, because you are sort of leaving the control flow of your application and going into the virtualized environment. So yeah, I'm sorry for like the jerk answer. Like it does depend, but I think like if you're using what I believe your definition of unit test is here, then yes, like this is not an integration test in the sense that you don't have external services that you have to run in order to get the test to work. Let me know if that answered things, Bunny.
Yeah. I think some comments from Bunny, which is, yeah, pre-cloud sanity check. But also, I think this one makes sense, where you want to catch like compile errors prior to compile. Okay, nice to catch more errors before deployment as well. Right, so yeah.
Yes, it's definitely a way to catch even more errors than you would catch. It's sort of you're running your application non-modified. You're just not running it in the exact kind of real environment that you would run in production. But does anybody ever test? Like,
Yeah.
Sure, people test in production all the time, but like not in CI. Hopefully, not in CI. You're not running against your production environment, so you're always going to be in CI running against some sort of like pseudo environment. And this is just a pseudo environment that happens to be very easy to set up and very fast to run, because it's all WebAssembly, and you never leave the process. You just stay in WebAssembly all the time, so it can run very, very quickly.
Nice. Marco, I see you can also do network mapping and penetration. I don't know too much about the testing world, about like penetration testing and network mapping and stuff. Ryan, do you know?
If you mean by network mapping and in terms of being able to say which I'm not, I also not sure if I fully follow that. So Marco, what you exactly mean by that would be interesting to hear. You can map between different host names to which response they can return back, which might be what you mean by network mapping, but I'm not sure.
Yeah. And yeah, folks, if you have follow-up questions, feel free to put them in chat. Bunny also says, right, agree. Like, I think the term unit test itself has become fairly broad right now. So it is kind of a fuzzy term. Yeah.
Yeah.
All good, Bunny. All good.
Yeah, all good.
Cool. Yeah, Ryan. So I think that was a great demo. I think I sort of also have got like a better grasp of how this would fit into like the development of like a Spin app or a WebAssembly app. Any last things you want to show us or talk to us before we wind up?
Sure. This is getting into let's see, a little bit of the underlying how this works. I'd like to shout out this Bytecode Alliance project called WAC, which Spin Test is built on top of. WAC stands for WebAssembly Composition tooling. And as we've talked about before, how Spin Test works is to take your Spin application and this virtualized environment, which is itself just a component, that's all it is, and compose them together. It uses WAC to do that composition. And so you can take a look at WAC, which is a very interesting tool. It comes with its own language about how to do composition, as well as some kind of tooling around that. This is a little bit more low level, but definitely something to play around with about how to take various components that exist and compose them into new components. So I definitely want to shout that out.
Awesome. Yeah, check it out, folks. WAC. Yeah, I think we've briefly spoken about this on one of our earlier streams, but yeah, do check it out. Awesome. So yeah, I think that's it, Ryan. Any last words about either Spin Test or testing WebAssembly apps?
I'd say just come on over to Spin Test, check out the repository, give it a try on your own apps when you're writing your own Spin apps. If you find it difficult to get into, we have examples here where you can see how this is meant to work. We haven't written sort of a comprehensive guide for exactly how to use that yet. So if you are getting lost or not exactly sure how to start, leave us an issue here and let us know what your experience is like. Again, this is very early days, so the likelihood that you might run into a bump here or there is somewhat high. But we're like very, very keen to get feedback on what this is like. And of course, if you want to contribute as well, it's all open source. So kind of come on over, and the code is fine, and we can work on this together. So
Awesome. Yeah. Before we wind up, I want to shout out two things. One is, if you're not part of our Discord already, do go ahead and join our Discord channel. I'll just put up the link there. Yeah, and most of us hang out in our Discord. So if you have any questions, if you want to show off your cool WebAssembly project, the Discord is the place to do so. Lastly, Spin is getting more and more popular. It is fully open source. And so far, we have done community calls for folks in the Spin community, and we've run that once a month. But I have very exciting news that we're actually moving to a fully open planning process for Spin. Only because, the scope has become bigger and there are so many people contributing to this amazing open source project. So check out this blog. I put the link in the chat. We're actually moving to a weekly cadence of Spin project planning calls. We do one that's a little catered towards the European and maybe even Asia time zone, and one catered towards North America and South America. All the details are in the blog post, but it would be awesome if you're interested in Spin for you to join in the calls. Again, moving to a fully open planning process with weekly project calls. So yeah, if you want to meet any of the engineers or contributors of Spin, that's the place you can actually do so. Including Ryan will be there sometimes, I assume, as well.
yes, I will.
Okay, excellent. All right, folks. So we are going to end the stream. Next week, we are speaking with folks from Rancher. We are going to do a run of SpinCube on Rancher Desktop and go through some of the cool things that you can do with that. The new release of Rancher Desktop actually has support for SpinCube, so we will be talking about that. If you don't know what any of those words mean, then join the stream and we will explain to you what it does as well. So see you next week. And Ryan, big thank you and big shout out for doing the stream with us and for authoring Spin Test. And yeah, hope to see you soon again on the show.
Yeah, thank you. Thanks for having me.
All right. Take it easy, folks. Bye-bye.
Bye.